Hi, this video is going to help with section 11.1 in geometry, or it kind of goes over Euler's formula and looking at different shapes that are 3D. So I have some 3D examples here for you that I'm going to show you. So let's look at this formula first. It says the sum of the number of faces, and those go by an F, and the vertices, V, of a polyhedron is 2 more than the number of its edges. So that's kind of the formula that they give you here for it. And let's look at basically what is it referring to. So the different shapes that you see that I have here are all polyhedron. They're all a 3D type shape. And so the polyhedron, it says the faces, so polyhedron, it can't be a cone on a polyhedron because it doesn't have pointy edges. So the edges that they're referring to are here, and then the vertices are the corners. So the edges are all the little straight spots. Vertices are the corners, and then the faces are the flat piece. So when it is saying that the number of faces and vertices of the polyhedron is 2 more than the number of its edges. So the faces and the vertices, you add all those up and it equals the edges plus 2. So all the edges plus 2. I don't know if you'll use that formula a lot, but they refer to it. I mean, you can count the pieces without talking about, you could count up the edges, the faces, the vertices, the edges, and all that without needing any kind of formula. But we'll look at how we can use it a little bit. So a hexagon, all right, let's look at some words of these pieces. I forgot to grab my other pieces, which are right here. Hang on just a sec. I just got out a couple that I was going to use for this example. When I look at all these pieces here, let's think of names for them. First of all, we have a sphere. That's round, right? We have a cone. Looks like an ice cream cone. And then we start to talk about, and a cylinder. Most of us know what a cylinder is. We start to talk about pyramids, and we talk about prisms. Prisms have the same shape on the bottom as they do on the top. So this one here is a prism, and is a hexagonal because it has a hexagon on its top and bottom. This is a triangular prism, and notice the sides are rectangles. That's true for every prism. Okay, here's another prism that's a triangular prism, different, but right, these are different than each other. See them? But they're still the same shape. This is a square prism. Both the bottoms and tops are square. This is a cube, right? Cube just means all the sides are the same. Definitely aren't the same. Square prism, the sides are longer. This one is a cube. Okay. If I'm going to call a pyramid something, all right, so here's a pyramid, here's a pyramid. What's the difference? You guys are looking down on them on here. So what's the difference on this one is the bottom is a square, right? And the bottom of this one's a triangle. So you that does make them different for a pyramid. I think I called them a prism, but they are a pyramid. So we'd call this a triangular pyramid. This one a square or rectangular pyramid, depending on kind of how this one's a square, but some of them might be rectangle. All right, so there's my shapes to kind of help, and then I'm going to leave a couple out for my next example. What if I'm looking at a hexagonal prism? So here's my hexagonal prism, and I am told that the number of faces is equal to 8 and the vertices is equal to 12. How many edges does it have? Well, we could use Euler's rule and we could say, okay, well, 8 plus 12, because he says faces plus vertices has to equal our edges plus 2. And you could figure it out that way. So, excuse me, 8 and 12 is 20. Then subtract your 2 over and you have 18 edges. All right, well, I could count those. It'll take me a while, but that's okay. 1, 2, 3, 4, 5, 6. 6 here. 7, 8, 9, 10. I might count these wrong. Wait, maybe make sure I mark this one. Okay, so 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18. So that's how you can see the 18 edges. All right. And then what if I have a triangular prism and I am told the edges, there's 9. Faces are 5. Oops, doesn't look like an F. There's 5 faces. Well, how many edges are there? No, vertices. Duh. How many vertices are there? So we're saying, okay, edges are 9, faces are 5. Well, we can use the formula of 5 plus our vertices is equal to our edges, which we know is 9 plus 2. 9 plus 2 is 11. And then you have to subtract your 5 over, and you'll see 6 vertices. Or you could have counted them. 1, 2, 3, 4, 5, 6. Either way. Okay, what about cross sections? Well, let's look at some of these shapes. Oh, good, I didn't move my shapes. What if I have a cone, and I'm looking at this cone? What if I cut the cone right here? Just slice it down here. What shape will you see? Well, here, this will help. It'll be like looking down. What shape is that? A circle. So cross section of a cone is a circle if I go this way. What if I went this way? Okay, so then you're going to visualize it this way, right? What's the cross section look like? A cone shape, right? What's the cross section of, here's a cylinder. What's the cross section this way? A circle. What's the cross section this way? So if I slice that paper down, you'd be looking down this way. Can you tell what that is? It's a rectangle. So with the ones that are cross section, just do your best. You're just looking at the cross sections and deciding what shape they are. The last thing that the book kind of covers is, well, what if I rotate something around this circle? So I'm making it into a 3D shape. So visualize that, rotating, rotating, rotating. What's it going to look like as it rotates around and forms that shape, that rotation? Well, for this one, it's going to look like a sphere. So if you keep rotating it, it's going to become a circle. All right. So there's your help with this section. This was quick, but you should be able to do this section quick.